Hi, hello there. Welcome to ICMP. Imagine that you have an intricate model train set. Your tracks and trains are all connected and powered up and ready to go. You throw the switch. The train goes halfway around the track and stops. You know right away that the problem is most likely located where the train has stopped, so you look there first. It is not easy to visualize this with a network. Fortunately, there are tools to help you locate problem areas in your network, and they work with both IPv4 and IPv6 network. This module, ICMP, is divided into two sections. So you've got ICMP Messages and the ping and traceroute testing. So this video lecture is entitled ICMP, and at the end of this video lecture, you should be able to use various tools to test network connectivity. Let's get started with ICMP Messages. In this topic, you will learn about the different types of Internet Control Message Protocols, or ICMPs, and the tools that are used to send them. Although IP is only a best effort protocol, the TCP/IP protocol suite does provide for error messages and informational messages when communicating with another IP device. These messages are sent using the services of ICMP. The purpose of these messages is to provide feedback about issues related to the processing of IP packets under certain conditions, not to make IP reliable. ICMP messages are not required and are often not allowed within a network for security reasons. ICMP is available for both IPv4 and IPv6. ICMP v4 is the messaging protocol for IPv4. ICMP v6 provides these same services for IPv6 but includes additional functionality. In this course, the term ICMP will be used when referring to both ICMP v4 and ICMP v6. So the types of ICMP messages and the reasons why they are sent are extensive. The ICMP messages common to both ICMP v4 and ICMP v6 and discussed in this module includes host reachability, destination or service unreachable, and time exceeded. So take note that ICMP v4 messages are not required and are often not allowed within a network for security reasons. Host reachability. An ICMP echo message can be used to test the reachability of a host on an IP network. The local host sends an ICMP echo request to a host. If the host is available, the destination host responds with an echo reply. Now in this diagram here, in the figure, okay, so it shows a request and an echo reply from the network. So basically host 1 is looking for host 2. Okay, so is host 2 reachable? So host 1 will be sending an ICMP echo request to host 2. And host 2, being available, should reply with an echo reply, going back to host 1. So this use of the ICMP echo messages is the basis of the ping utility command. Destination or service unreachable. When a host or gateway receives a packet that it cannot deliver, it can use an ICMP destination unreachable message to notify the source that the destination or service is unreachable. The message will include a code that indicates why the packet could not be delivered. So some of the destination unreachable codes for ICMP v4 are as follows. So you've got 0, net unreachable, 1, host unreachable, 2, protocol unreachable, and 3, port unreachable. So some of the destination unreachable codes for ICMP v6 are as follows. So you've got 0, okay, no route to destination. 1, communication with the destination is administratively prohibited. Example, firewall. Okay. 2, beyond the scope of the source address. Address unreachable for 3, and 4, port unreachable. So take note that ICMP v6 has similar but slightly different codes for destination unreachable messages. Time exceeded. An ICMP v4 time exceeded message is used by a router to indicate that a packet cannot be forwarded because the time to leave or TTL field of the packet was decremented to 0. If a router receives a packet and decrements the TTL field in the IPv4 packet to 0, it discards the packet and sends a time exceeded message to the source host. ICMP v6 also sends a time exceeded message if the router cannot forward an IPv6 packet because the packet has expired. So instead of the IPv4 TTL field, ICMP v6 uses the IPv6 hop limit field to determine if the packet has expired. Okay, so take note that time exceeded messages are used by the Traceroute tool that we use on the command prompt. That's tracert, okay, or on the iOS, that is a traceroute. ICMP v6 messages. The informational and error messages found in ICMP v6 are very similar to the control and error messages implemented by ICMP v4. However, ICMP v6 has new features and improved functionality not found on ICMP v4. ICMP v6 messages are encapsulated in IPv6. ICMP v6 includes 4 new protocols as part of the Neighbor Discovery Protocol ND or NDP. So messaging between an IPv6 router and an IPv6 devices, including dynamic address allocation, are as follows. So you've got RS, okay, or router solicitation message. You've got RA, or router advertisement message. Now messages or messaging between IPv6 devices, including duplicate address detection and address resolution, are as follows. So you've got the neighbor solicitation, NS message, neighbor advertisement, NA message. So take note that ICMP v6 ND also includes the redirect message, which has a similar function to the redirect message used in ICMP v4. RA messages are sent by IPv6 enabled routers every 200 seconds. That is to provide addressing information to IPv6 enabled hosts. The RA message can include addressing information for the host such as prefix, prefix length, DNS address, and domain name. A host using stateless address auto-configuration or SLAAT will set its default gateway to the linked local address of the router that sent the RA. Okay, so as shown here in the figure, okay, R1 sends an RA message, hi all IPv6 enabled devices, for instance. I'm R1, and you can use a SLAAT to create an IPv6 global unicast address. Okay, now the prefix 2001 db8 acad :1::/64. Okay, by the way, use my link local address FE80, okay, ::1 as your default gateway. That is per R1. Okay. Now, an IPv6 enabled router will also send out an RA message in response to an RS message. So in the figure here, okay, so PC1 sends an RS message to determine how to receive its IPv6 address information dynamically. So of course, R1 replies to the RS message with an RA message. Okay, so PC1 sends an RS message. Hi, I just booted up. Something like, okay, is there an IPv6 router on the network. I need to know how to get my IPv6 address information dynamically. So R1 replies with an RA message. Hi, all IPv6 enabled devices. I'm R1. And you can use Slack to create an IPv6 global unicast address. So again, the prefix would be 2001 db8 acad :1::/64. Okay? By the way, you use my link local address fe80::1 as your default gateway. Now, when a device is assigned a global IPv6 unicast or link local unicast address, it may perform duplicate address detection or DAD, okay, to ensure that the IPv6 addresses are unique. So to check the uniqueness of an addresses, the device will send an NS message with its own IPv6 address as the targeted IPv6 address, as shown here in the figure. So if another device on the network has this address, it will respond with an NA message. This NA message will notify the sending device that the address is in use. If a corresponding NA message is not returned within a certain amount of time, the unicast address is unique and acceptable for use. So take note that DAD is not required, but RFC 4861 recommends that DAD is performed on unicast addresses. Okay, so again, in the figure here, PC1 sends an NS message to check the uniqueness of an address. So will whoever has the IP address 2001 db8 acad :1::10, okay, send me your MAC address. All right. Now, address resolution is used when a device on the LAN knows the IPv6 unicast address of a destination, but does not know its Ethernet MAC address. So to determine the MAC address for the destination, the device will send an NS message to the solicited node. So the message will include the known targeted IPv6 address. The device that has the targeted IPv6 address will respond with an NA message containing its Ethernet MAC address. So in the figure here, so R1 sends an NS message to 2001 db8 acad :1::10. Okay, so asking for its MAC address. So in the figure, okay, so R1 sends an address resolution or NS message. Will whoever has the IP address 2001 db8 acad :1::10 send me your MAC address. Okay, so as I mentioned earlier. Now PC1 replies with an NA message. I'm 2001 db8 acad :1::10. And my MAC address is, you've got 00 AA BB CC DD and EE. Ping and traceroute tests. In the previous topic, you were introduced to the ping and traceroute or tracert tools. Traceroute is for the iOS and tracert is for the command prompt on Windows. Now in this topic, you will learn about the situation in which tool is used and how to use them. So ping is an IPv4 and IPv6 testing utility that uses ICMP echo request and echo reply message to test connectivity between hosts. To test connectivity to another host on a network, an echo request is sent to the host address using the ping command. So if the host at the specified address receives the echo requests, it responds with an echo reply. As echo reply is received, ping provides feedback on the time between when the request was sent and when the reply was received. This can be measured of a network performance. So ping has a timeout value for a reply. If a reply is not received within the timeout, ping provides a message indicating that the response was not received. This may indicate that there is a problem. but could also indicate that the security features blocking the ping messages have been enabled on the network, like the firewall. It is common for the first ping to time out if address resolution, ARP or ND, needs to be performed before sending the ICMP echo request. So after all the requests are sent, the ping utility provides a summary that includes the success rate and average round-trip time to the destination. Type of connectivity tests performed with ping includes the following. So something like pinging the local loopback, okay, pinging the default gateway, and pinging the remote hosts. So an example of ping command is shown on this diagram here. So something like, if this switch 1 will ping 192.168.20.2, you've got the result of the ping here. So that includes sending 5 packets, okay, our information sent to 192.168.20.2. Okay, success rate is 80%. So if it is the first time, okay, so due to the ARP ND, okay, so we need to perform again the ping command so that you get 100% from this. But then we don't have problem with having an 80%. Okay, you could always redo it. Ping the loopback. Ping can be used to test the internal configuration of IPv4 or IPv6 on the local hosts. So to perform this test, ping the local loopback address of 127.0.0.1 for IPv4 or : 1 for IPv6. Okay, so a response from 127.0.0.1 for IPv4 or : 1 for IPv6 indicates that IP is properly installed on the hosts. So this response comes from the network layer. This response is not, however, an indication that the address or addresses, masks, or gateways are properly configured, nor does it indicate anything about the status of the lower layer of the network stack. This simply tests IP down through the network layer of IP. An error message indicates that TCP/IP is not operational on the hosts. Another is ping the default gateway. You can also ping the test or to test the ability of the host to communicate on the local network. This is generally done by pinging the IP address of the default gateway of the hosts. A successful ping to the default gateway indicates that the host and other router interface serving as default gateway are both operational on the local network. For this test, the default gateway address is most often used because the router is normally always operational. If the default gateway address does not respond, a ping can be sent to the IP address of another host on the local area network that is known to be operational. So if either the default gateway or another host responds, then the local host can successfully communicate over the local network. If the default gateway does not respond, but another host does, this could indicate a problem with the router interface serving as the default gateway. One possibility is that the wrong default gateway address has been configured on the host. Another possibility is that the router interface may be fully operational but have security applied to it that prevents it from processing or responding to a ping requests. The host pings its default gateway, sending an ICMP echo request. The default gateway sends an echo reply confirming connectivity. Okay, so basically the default gateway is set on the Internet Protocol version 4 or TCP/IP IPv4 properties on Windows or on IPv6. Okay, and pinging the default gateway will ensure that we have connectivity to the router. Ping a remote host. Ping can also be used to test the ability of the local host to communicate across the internetwork. The local host can ping an operational IPv4 host of a remote network, as shown here in the figure. So the router uses its routing table to forward the packets. If this ping is successful, the operation of a large piece of internetwork can be verified. A successful ping across the internetwork confirms communication on the local network, the operation of the router serving as the default gateway, and the operation of all other routers that might be in the path between the local network and the network of the remote hosts. Additionally, the functionality of the remote host can be verified. So if the remote host could not communicate outside of its local network, it would have not responded. Take note that many network administrators limit or prohibit the entry of ICMP messages into the corporate network. So therefore, the lack of ping response could be due to security restrictions. And also, you cannot be able to ping a remote host if the firewall on that host is enabled. Traceroute. Okay, so let's test the path. So ping is used to test connectivity between two hosts but does not provide information about the details of devices between the hosts. Traceroute in iOS or tracert in Windows is a utility that generates a list of hops that were successfully reached along the path. So this list can provide important verification and troubleshooting information. If the data reaches the destination, then the trace lists the interface of every router in the path between the hosts. If the data fails at some hop along the way, the address of the last router that responded to the trace can provide an indication of where the problem or security restrictions are found. So you've got the round trip time or the RTT. Okay. Now using Traceroute provides round trip time for each hop along the path and indicates if a hop fails to respond. The round trip time or RTT is the time a packet takes to reach the remote host and for the response from the host to return. So an asterisk is used to indicate a lost or unreplied packet. So the information can be used to locate a problematic router in the path or may indicate that the router is configured not to reply. So if the display shows high response times or data losses from a particular hop, this is an indication that the resources of the router or its connections may be stressed. IPv4 and IPv6 hop limit. So Traceroute makes use of a function of the TTL field in IPv4 and the hop limit field in IPv6 in the layer 3 headers. So along with the ICMP time exceeded message. Okay, so the animation here shows how Traceroute take advantage of the TTL value. So the first message sent from the Traceroute will have a TTL value field of 1. Okay, so this causes the TTL to time out at the first router. So this router then responds with ICMP time exceeded message. So Traceroute then progressively increments the TTL value. Okay, so 2, 3, 4, and so on. So for each sequence of the messages, this provides the trace with the address of each hop as the packet time out further down the path. So the TTL field continues to be increased until the destination is reached, or it's incremented to a predefined maximum. So that's the end of this video lecture. So see you on the next video lecture.